There we go. Okay. So yesterday where we stopped was, so we are talking about the changes that can be applied to the graphs, right? Okay, so remember there are two kinds of changes. One, you can change the position of the graph, but you don't ever touch its shape. So you can guess what the second change will be. It means change the shape as well, but that's coming later. Now, remember in the translation, which means we only change the position, there are two kinds, which is you move the graph up and down, which is pretty easy because you just have to add or subtract some number behind the functions, okay? So if you add something, that means you go up. And if you subtract something, you go down, okay? So it's really intuitive. Now, however, for the left or right, which means horizontal shift, we still add and subtract something, but not in the back from the function, but we add and subtract to x, okay? So that number stays within the parentheses, okay? And it seems like when we add something, we have to go to the right, but no, we have to think backwards, so you have to go left, okay? And if we subtract something, it seems we have to go left, but no, you have to think backwards, so you have to go right, okay? So the typical problems that you will see in the homework about this section is something like this. Describe how you can get the graph of the following new functions from x squared. Okay, so here, just for simplicity, let me call f of x to be x squared. Okay, so part A, it's x squared plus 3. So what does that mean? This is f of x plus 3, right? Okay, so now we are adding something, and where are we adding? Not within the parentheses, right? In the back, rather. Okay, so whenever we add something in the back, what does that mean? It's the vertical motion, right? Okay, and now since the vertical motion means it's the easy one, so what does that mean? We can just follow our intuition, right? So when we add something, that means we have to go what? Up, right? Okay, so this means we move x squared up, and then remember you have to specify the distance of the motion, right? And how do you tell how much we move? That's how much we add or subtract, right? Okay, so what does that mean? Move x squared up 3 units. Okay, so it's that simple. Okay, so that's it. Now, even though graphing is not part of this problem, let's sketch the rough graph. Okay, so we know the graph of x squared, right? The parent function. Okay, so it's a parabola, right? Okay, which is part of today's exam, right? It is opened upward, right? It is opened upward. Okay, so let's see. So the vertex is at the origin, right? Okay, so now you are shifting up 3 units. So what does that mean? So imagine applying your force like this direction. So what does that mean? Your graph will look something like this, right? I mean, like this was the x squared, and now that's x squared plus 3, right? Okay, make sense? So basically this graph is shifted upward. Okay, and what is this distance? 3, right? Because that's how much you have moved. Okay, so that is the new graph. Okay, I'm just drawing the graph of x squared just to compare how both graphs are positioned. Okay, and now another thing. So in this homework, homework number whatever, 14 or so, you will see a few graphing problems. And remember, so far, in order to graph, say, a line, you needed 2 points, right? And then you have to plot them on the xy plane, and then you have to graph it, which is something that you have seen or will see on today's exam, right? Oh, I'm just revealing one of the problems. There we go. How generous I am. Anyways, and then in order to get the graph of like this parabola, you need what? You need 3 points at minimum, right? Okay, which could be part of today's exam as well, but obviously I cannot tell you. But so here, to sketch the graph of x squared plus 3, you might think, oh, so I need to pick 3 points and then plot them on the xy plane. Now, the thing is, just for this homework, you cannot do that. You have to use something else, okay? So when you do the graphing problems on the homework, so let's say you are sketching the graph of x squared plus 3, okay? Then what you have to do is start from the graph of x squared, okay? So start from the graph of x squared, okay? So you know what to do. So like pick 3 points and then just get this graph, okay? Now, once you do that, you will see this like pop-up screen thing on your homework, okay? Like this small pop-up screen. And there are a bunch of words and numbers. So the default setting looks like this, like V shift, and then H shift, and then V stretch, and horizontal or H stretch, okay? So now, V stands for vertical, and H stands for horizontal. Oops, horizontal. Okay, so it will say vertical shift is equal to something, and then horizontal shift is equal to something, and then vertical stretch is equal to something, and horizontal stretch is equal to something. Now, we have not yet covered the stretches, the horizontal and vertical stretches, but we'll cover that maybe today or tomorrow. But the default setting is this one, okay? So for all the shifts, 0 will be the default setting, which means there's no shift at all. And for the stretch, the default setting is 1, which means there is no stretch at all, okay? And now once we cover the stretch, I will tell you why 1 is the default setting, not 0 for the stretches. But for right now, that is the default setting. So you have to change these numbers, okay, according to what you have done to this new function x squared plus 3, okay? So that's the default setting. So how should you change this window? Now here, are we stretching this x squared at all? No, right? So what does that mean? For all the stretches, you just keep them as 1, okay? You don't change this number. And now, are you shifting, or are we shifting vertically? Yes, right? And how much are we shifting? By 3, right? So what do we have to do? Under the vertical shift, you have to put 3, okay? Because that's how much we add at the end, right? Okay, and now, are we shifting horizontally? So that means, are we going left or right? No, right? So what does that mean? For the horizontal shift, you have to keep it as a 0. Okay, so just change this number from 0 to 3. Okay, and then once you change this pop-up screen into this, and then click whatever, like next or enter, you will get the graph of this. Okay, does that make sense? Like I'm mentioning this because you cannot get the graphing problems done in a normal way in this section. Okay, yeah, I honestly am not a fan of this. So for the exams, I don't know, like for the paper exams, I don't recommend students to know this, but for the MyLabs Plus problems, which is part of exam 3, you may have to know it. I'll have to double check because I forgot what kind of problems are on exam 3. Okay, so I can give you more information about that later, but there could be problems that you may have to change the numbers like into this format. Okay, so we will practice this like 1,000 times in the future problems. So if you think this is just really weird, no worries, you'll get used to it. Okay, so now part B, x minus 4 quantity squared. Okay, so now for this problem, please do not FOIL this x minus 4 squared. Okay, that's not the point. Now, since x squared is f of x, this is equal to what? F of x minus 4, right? Okay, so what do you notice here? We subtract something to x, okay, not in the back, right? Okay, so what does that mean? Is it vertical motion or horizontal motion?
Horizontal.
Yeah, horizontal, right? Okay, now it seems like when we subtract something, we have to go left. But remember, for the horizontal, you have to think backwards, right? So what does that mean? Go right, right? Okay. Remember, for the horizontal, you always have to think backwards, okay? So move x squared right 4 units, okay? So that is the change that has been applied to x squared. So now, in terms of the graph, how does it look like? So this is the graph of x squared, right? And now you are shifting it to the right. So what does that mean? You are applying your force like here, right? Okay, so you are like pushing like this, right? Okay, so how does the graph change? Something like this, right? Okay, so that's the graph of this x minus 4 quantity squared. Okay, and what is this distance? That distance is 4, right? Okay. So that's the graph of x minus 4 squared. And now, let's practice this weird pop-up screen thing, okay? So now, this time, how should we change? So this time, are we shifting vertically? No, right? So what does that mean? So this time, our vertical shift is just 0 as it is, the default setting. And now, are we shifting horizontally? Yes, right? So we are shifting horizontally. So what do we have to put? Instead of 0, we have to put minus 4. Okay. Now, what some people think and misunderstand is we are going to the right, so it seems like we have to put just positive 4. But no, like if you think really simple, that's how much we subtract from x. Okay, so we don't just put plus 4 even though we are going in the positive x direction. We put minus 4 because that's how much we subtract, okay, from x. Okay, so even though we are going to the right, we have to put negative 4, not positive 4. And then all the stretches, well, we are not stretching at all, so just same as 1, right? Okay, so we just keep them as it is. Okay. Again, once we cover the stretches, I will tell you why 1 is the default number for no stretch, whereas 0 is the default number for no shift. Okay. Okay, so that is B. And now, can I go to the next page? Yeah, okay. So now, part B or C, x plus 2 quantity square minus 5. Okay, so now again, no FOIL on x plus 2 squared. Okay, now here, how many changes are applied to the parent function x squared?
2.
2. Do you see them? The plus 2 and the minus 5, right? Now, what does that plus 2 represent?
Horizontal shift.
Yeah, so where do you go? Left or right?
Left.
Left, right, yes. Okay, when we add something to x, it seems we have to go right, but no, we have to think backwards, right? So this means we go left too. And now, what about that -5 in the back? Is it right 5 because we are subtracting? No, -5 is in the back, right? Okay, of something squared. So what does that mean? This one is down 5, right? Okay, so what's the answer? It's these two, okay? So move x squared left 2 and down 5. So now, how does the graph look like? So the graph of x squared is this one. Okay, and now first you go left. So what does that mean? You are shifting this graph to the left, this direction, right? So we have something like this. Okay, now question, why did I draw a dotted parabola, not a solid parabola?
Because it's only one shift.
Right, because I'm not done, right? Okay, that's not the final graph, right? And now what do you have to do on this dotted parabola? You have to pull it down, right? Okay, by what? 5 units, right? So how does the graph look like? Something like this, right? Okay, so that is the graph of x plus 2 squared minus 5. Okay, so now that pop-up thing, okay, just keep appearing. So here, are we doing any vertical shift? Yeah, right, because we have moved down, right? Okay, and what do we have to put? -5, right? Because that's how much we subtract at the end, right? Okay, it's -5. And now, are we doing any horizontal shift? Oh yeah, right? It's 2, right? Okay, and remember, even though we are going to the left direction, we have to put just 2, right? Because that's how much we add. Okay, we don't put -2. And now, what about the stretches? It's all 1, same as before, right? Because we are not stretching at all, okay? Okay, so just keep in mind that you may see the combination of the vertical shift and horizontal shift, not just either one, okay? Any questions on these translations? Okay, so now let's go to transformation, okay? So transformation. What does transformation mean? We now change the shape. Okay, now what does this mean? What does this mean? Does the position change as well? Okay, so here, one example of transformation is vertical stretch and shrink, which we will cover in a minute. Now, what does that mean? You stretch means this, right? Vertical stretch. Okay, and what about shrink? It's compress, right? Okay, so that's what it means. So for example, for the x squared graph, okay, that looks like this. So imagine you are stretching it vertically. So what does that mean? You can, so suppose you can grab this graph and you are applying your force like this, right? Okay, that's how you stretch, right? Okay, so how will the graph look like? It will be kind of skinnier, right? Like that. Okay, so on the same xy plane, it looks like this, right? So what do you notice about the position? So in particular, the position of the origin doesn't change, right? The anchor point or the vertex stays the same, okay? But what about the position of like these points? Do they change? Yeah, right, because these will be moved to here and here, right? So what can you say about the position in general? It's automatically changed. Okay, even though you don't mean to, and there could be points that's not moved. Okay, but in general, the position is automatically changed when you apply these transformations. Okay, so now the first transformation is, like I said, vertical stretch and shrink. Okay, so vertical stretch and shrink. And remember, whenever you see the word vertical, it's pretty easy to understand. The tricky thing is the horizontal case, right? Because you have to think backwards. Okay, now the setup of the stretch and shrink is this one. What does that mean? You multiply some number, which is positive number, in front of your function. Okay, so that's the basic setup. Now, there are two cases. So a is greater than 1. Okay, so when you multiply some number greater than 1, so for example 2, 3, 4, or so on. Okay, so now think about it. If you multiply 2, 3, or 4 in front of your function, does it sound like it's a stretch or shrink? So that's kind of like bigger number. Is it stretch or shrink? What do you think?
Stretch.
Stretch, yes. Okay, so this means stretch f of x. And now, instead of by like how many units, we have by a factor of. Okay, and what's the reason? Because here, going back to this kind of ugly picture here, it doesn't make sense to talk about the distance of stretch, right? Because like, what's the distance of stretch? That doesn't make sense. Because here the distance is all different, right? Because like here, that's the x square graph, and that's the stretch version. And that distance is not the same thing as that distance, right? So specifying the distance doesn't make sense. Rather, you can tell what? By how strong you stretch, right? And how weak you stretch. So what does that mean? By a factor of how much you multiply in front. Okay, so that number denotes how strong you stretch. Okay, and conversely, what does shrink mean? Your A is less than 1. Okay, and again, by a factor of the same number. Some people think for the shrink, they have to put like 1 over A for this number here, but no, just A stays the same. Okay, and now, question, where is the case where A is equal to 1? So here we have greater than 1, and here we have less than 1. Where is the case where A is equal to 1?
Wouldn't it be the parent function?
Do you see that? What happens when A is equal to 1? It's 1 times f of x, right? And what is 1 times anything? Itself, right? Yeah, okay. So A equals 1 is meaningless. Okay? And now going back to this this pop-up screen thing, why is 1 the default setting for the stretch? Because when you put 1 in front, like I said, like 20 seconds ago, what does that mean? You don't change your function, right? Okay, so that's why 1 is the default setting for all the stretch and shrink. Whereas the shift, y is 0 the default number, because when you add or subtract 0 to x or in the back, you don't change your function, right? Okay, so that's why 0 is the default number for the shifts, not 1. Okay, so that was the reason. Okay, so now there is a notion of the horizontal stretch and shrink. And now, maybe you can take a guess what the setup of this horizontal stretch and shrink is. So for the vertical stretch and shrink, we multiply a number in front of the function. So what will be the setup for the horizontal stretch and shrink? We multiply a number to x, but still within the parentheses. Okay? And remember, the word horizontal makes you think backwards. So what am I mean by that? When a is greater than 1, it's a stretch for the vertical transformation. So what would be the case when this number is greater than 1? Is it going to be stretch or shrink in terms of horizontal way?
It would shrink, wouldn't it?
Shrink, yes. Okay, so you have to think backwards for the horizontal. It's the shrink. Oops. Shrink. Okay, and then for the number being less than 1, it seems like we have to shrink, but no, you have to think backwards. So this one is a stretch. Okay, so that is the setup of the horizontal stretch and shrink, which you might have to use it on some problems in your homework, but you don't have to know this. And I will tell you why once we do the problems. Okay, so now the second kind of transformation is the reflection. Okay, and what's the way to tell whether something is a reflection or not? It deals with the negative sign. Okay, so whenever you see the negative sign somewhere in your function, that means the reflection has been applied. Okay, now please don't say, well, that's the negative sign. Well, that's not the negative sign, right? That's the subtraction sign. Okay, so not that negative, but the real negative sign. Okay, and this one is also tricky because you have to think backwards once again. Okay, so now there are three kinds of reflections: over the x-axis, over the y-axis, and there's one more, over the origin. Okay, but I didn't include it here, and you'll see why. Okay, you don't have to know it either. So now there are two kinds of reflections. Number one, the negative sign is in front of x. Okay, so what seems to be the case? Oh, so negative sign is in front of x. So that means reflect across the x-axis. That's the natural reaction, right? But no, think backwards. Reflect over the y-axis. Okay, so again, you have to think backwards here. Negative sign in front of x, reflect over y. Okay, and now second case, negative sign is in front of every function. Okay, so remember f of x is same thing as y, right? So what does it mean? Negative sign is in front of y. So what does it mean? Oh, it seems like we have to reflect over the y-axis, but no, think backwards. Okay, so again, it's the opposite. Okay, so basically, in summary, the horizontal shift and stretch and shrink and reflection, those are the opposite schemes. Okay, in other words, you have to think backwards. Whereas anything that comes with vertical is intuitive. Okay, so let's apply these into the following problems. Okay, so it's the exact same problem as before, but the parent function has been changed into square root of x. Okay, so part A, we have 3 times square root of x. So what is this? 3 times f of x, right? Okay, so now, what does this mean? The vertical stretch and shrink, or stretch or shrink, or horizontal stretch or shrink?
Vertical.
The vertical, right? And is it stretch or shrink?
Stretch.
That's the stretch, right? And what's the reason? That's the number in front of the function, and it's greater than 1, right? Okay, so this one is a stretch square root by a factor of 3. Oops, by a factor of 3. Okay, so now, how does the graph look like? So, do you still remember the graph of square root? Yeah? No? How does the graph of square root look like? Yeah, it's this one, right? Okay. Now, you are stretching this, and here, if I want to be kind of specific and picky, I can put vertical stretch. So vertical stretch means what? Suppose you can grab this graph, okay, and you are pulling this graph upward, right? Okay. Now, when you stretch it, does this anchor point change? No, right? So how does the graph look like? Something like this, right? Okay, so what do you notice here? It is the steeper curve, right? Okay, the slope is kind of rapidly increasing, right? Okay, so that was the graph of square root of x, and that's the graph of 3 square root of x. Okay, and this anchor point does not change. Okay, and now, that pop-up thing, okay, appears once again. So now here, are we shifting square root of x at all? No, right? So what does that mean? For all the shifts, you just keep them as 0, right? Because we are not shifting this at all. Now, are we stretching or even shrinking vertically? Yeah, right? We are stretching vertically, right? And here, what do we have to put? 3, which means what? By how much we multiply in front, right? Okay. And now, are we doing any horizontal stretch and shrink? No, so we just keep it as 1, right? The default setting. Okay. Okay, so now that is A. Can I go to the next page? Yeah. Okay. So now part B. Square root of 1/2 x. Okay. So now here, actually, this problem can be done in 2 ways. Okay, which does not matter at the end, but it kind of matters for the graphing problems in your homework, and I will tell you why. Okay, so now first, let's use the vertical transformation. Okay, so that means vertical stretch and shrink. Okay, so now this is equal to square root of 1/2 x. So remember, the setup of vertical transformation is this one, right? Some number times f of x. Okay, what should this number be in this case? hint. It's a tricky question.
1.
1? It's not 1 because it's square root of x for the f of x, and if it were 1, we have to have just square root of x. So what seems to be this number? 1/2, right? Because that's what's been multiplied, right? Now, what happens when a is 1/2? What do we have? 1/2 times square root of x, right? But is that what we have? No. The 1/2 is under the square root, right? Okay, so how can we get this number in front? Here is my hint. 1/2 times x. Does it remind you anything?
It's a horizontal shift.
Yeah, there is a way to do this problem using the horizontal transformation, yes, but we will cover that in a minute. Okay, now here we have a product under the square root. So what can we do? So like, for example, if you have something like this, okay, it's square root of 16, yes, but what can we do?
Split each one.
Split, yes, okay. So this is equal to square root of 1/2 times square root of x. Okay, because we can split the square root. Okay, now do you see the number in front of the function? What's the number in front? It's not the 1/2, right? It's what? That, right? Okay, so that's the number in front. So now, is this less than 1 or greater than 1?
Less.
Less than 1, yes. Do you see why? Okay, so 1/2 is less than 1. So what happens when you take the square root on both sides? Square root of 1/2 is also less than 1, right? Okay, so a is also less than 1. So now, what does it mean? For the vertical transformation, when the number in front is less than 1, is it stretch or shrink? Shrink, right? Because we are just thinking in a normal way, right? Okay, so this one is a vertical shrink by a factor of square root of 1/2, right? Okay, so again, this was your a, right? Okay, so now, that's fine. And now let's do this problem in a horizontal transformation. Okay, so now remember the setup of horizontal transformation is this, right? The number is in front of x, right? So now from here, can you see what a should be?
One-half.
Just 1/2, right? Yeah, okay, so now here, a is now 1/2, which is less than 1. Okay, so now, what does it mean in terms of the horizontal? It seems like it's a shrink, but you have to think backwards, right? So what is this? This is horizontal stretch by a factor of 1/2. Okay, so now, here is my next question. Are they the same? Okay, so it seems like they're different, right? So let's see. Let's sketch the graph. Okay, so here is the graph. So we know the graph of square root of x. That looks like this, right? Okay, now Suppose you vertically shrink this graph. So what do you have to do? Suppose you can like press this curve, right? From the upward direction, right? So you are pressing this graph. Now, what happens to this tail? Is it more closer to the x-axis or is it more closer to the y-axis like this when you compress it? It goes like this, right? Like when you push it hard from the top, right? Okay, so that's the graph of the square root of 1/2 x. Okay, now, is this the graph that you get when you horizontally stretch this square root of x? Okay, now what do you have to do in order to stretch horizontally? Suppose you can grab this tail, and where do you have to go? Like this, right? You have to like pull, in your view, this way, right? Okay, you have to grab it and then you have to go this way, right? So do you get the exact same graph? Yes, right? So yes, indeed, they are the same. Okay, so what do you notice here? The horizontal stretch is same thing as vertical shrink. And what can you say about vertical stretch then? It will be same thing as horizontal shrink. Okay, and that's why I said earlier, you don't really have to know this horizontal stretch and shrink. But of course, it's worth to know it, but you don't have to really memorize it, okay? Because you have to think opposite for the horizontal case, okay? Now, one more thing, one final thing for today. So let's go back to that pop-up screen thing. Okay, now, first of all, for all the shifts, vertical and horizontal shifts, are we shifting at all? No, right? So we just keep them at 0, right? Okay, now, we just saw that horizontal stretch and the vertical stretch or vertical shrink are the same things. Okay, so in particular, we have to put something under these vertical and horizontal stretches. But what do we have to put? So suppose we chose vertical shrink. Then what do we have to put under here? Square root of 1/2, right? Okay. Now, one small issue is that you cannot type the square root under this pop-up screen. Okay, even though there's a like little symbol toolbox that you can use, you cannot really type the square root. So what is the better approach? This one. Okay, because at least this one doesn't have any square root. So what do you have to put? 1/2 under the horizontal stretch and shrink. Okay, and then keep 1 for the vertical stretch. Okay, so that's what you have to type. Okay, so again, horizontal stretch and shrink is the opposite of vertical stretch and shrink, which is why you don't have to really know it. But for some problems, it's worth to use it, okay? Because like this one, you don't have to really use the square root. Okay, so that's it for today.